Now, when we go to label our normal distribution, we need to be a little bit careful to be specific about what we're talking about. That is, we can be talking about data from a sample. Or maybe we're talking about data from a population. That is, we either know stuff only about a subgroup or a smaller group, or we know stuff about everyone. And the notation we use for these is different. And to remember that, we need to think back to that first week where we covered all of our notation. Now, the notation for average of a sample is X bar. This is like the average of your group of friends or the average of our class. The average for a population is a little different. This would be like the average of all students at Loyola, or the average of everyone in the U.S. The average, when we talk about the population, is represented by mu. We also have different notation for standard deviation. And this would be like, once again, the standard deviation of your friends, or the standard deviation of our class, and it's represented with S. Down here, we'd have the standard deviation for everyone. That is, the standard deviation of all college students, or standard deviation of everyone in the U.S. And the symbol for that is a sigma. For this reason, when we go to label our normal curve, we need to know which one we're dealing with. If we're dealing with a sample, then in the very center will be X bar. And when I go one standard deviation out, this will be like X bar plus S. 2 standard deviations out, X bar plus 2S. 3 standard deviations out, X bar plus 3S. I can label the same over here with a minus instead. When I go to label the distribution for my population on the bottom, it's not X bar in the center, it's actually mu. And then mu plus sigma, and then mu plus 2 sigma, and then mu plus 3 sigma. I'll label the same over here on the other side. The only difference is I have a minus instead of a plus. Now, this might seem like a very, very minor thing, but it's important to use the right symbols when we're talking about our data. That is, it makes a huge difference if you just sampled like a couple people or even 1,000 people, or if you sampled everyone in the entire group. If the data from our sample is normally distributed, then we can say our sample is approximately normal with an average of X bar and a standard deviation of S. If our population is normally distributed, we can say it's approximately normal with an average of mu and a standard deviation of sigma. This is important to look at as well when you're doing problems. That is, if we're using X bar and S, we're talking about a limited sample. If we're using mu and sigma, we're talking about it being universally true within the entire population. We'll also use mu and sigma if we're talking about something we know for certain, such as rolling a dice. Like, you can do whatever you want with the dice, but there are certain given probabilities for what I will roll on average, how often I would roll a 1, a 2, a 3, a 4, a 5, or a 6. So that is, when we talk about probability that are known, a lot of times we'll use mu and sigma. This has gone ahead and overviewed the different notation we would use for data from a sample versus data from the entire population in terms of what it looks like on the normal distribution itself.